In this video, we are going to talk about a parabola, all right? A parabola under conic sections. Actually, a parabola is a conic section. A conic section is formed when a plane intersects a right conical surface. That is when a conic section is formed. And we have the ellipse, the parabola, and the hyperbola. So in this video, we are going to talk about a parabola. Now, what is a parabola? I think it is good for us to start by saying what a parabola is. Now, this is what a parabola is. A parabola is the set of all points in a plane such that the distance of each point from a fixed point that we call the focus is equal to its distance from a fixed line called the directrix in that plane. This is what we're talking about. And this is the y-axis. This is the parabola, or this curve, okay? We are saying that the parabola is the set of all points in a plane such that the distance of each point from a fixed point f, which is the focus. Now, let me label or fix a variable point on the parabola called point P, all right? Coordinate x, y, okay? So, we are saying that the distance of this point, for example, from a fixed point called the focus, let us define the focus F. We are going to state the point. This is the focus. The distance between this point and the focus is equal to the distance from this variable point to this line. This line is called the directrix, the directrix. Okay, so this is it. The distance from here to here is the same as the distance from here to here. Pardon my drawing, these two lines are equal in length. So this is the directrix. This line D is called the directrix. This point is called the vertex. It is the turning point on the parabola. It is the point where the parabola changes direction. This point is also the origin of the, where the x and y plane intersect. This point is the origin, x equal to 0, y equal to 0. So we can see that the vertex of this parabola is at the origin. So here we are trying to consider the equation of a parabola where the vertex is at the origin. Okay, so the distance from this vertex to the focus, is the same distance from the vertex to the directrix. At this point, it is 0, 0. Okay, that is the coordinate of the vertex. Now, you will agree with me that if the distance of this vertex to the focus is the same as the distance of this vertex to the directrix, that means they have equal length. So if, for example, here is 2 centimeters, this line is 2 centimeters long from the vertex to the focus, that means this will also be 2 centimeters long, even if they are in the opposite direction. This is the positive y-axis and this is the negative y-axis. This is the positive x-axis, this is the negative x-axis. Okay, so at this point, it is 0, 0. So at this point also, x is equal to 0, but y is not 0. So since this is the positive y-axis, let us label a point A for y. Alright? So at this point also, it is x is 0, but y is not 0. Y is minus A. At this point, where this y-axis and the directrix intersect, we are saying that from here to here is A. From here to here is also A, but it is minus A because we are talking about the negative x, the negative y-axis. What would this point be, for example? Okay, let's label this point. Let's say point Q. This is the origin where x is 0, so x is also 0 here. But at this point, x is not 0. So let's say it is x, for example, okay? And the corresponding y value is minus A. The minus a flows, actually, it is the value of y at this point. It's a straight line. So here's minus a, here's also minus a. I want to use this point to determine the equation of the directrix. That's the purpose of determining these 2 points. For a straight line, the directrix is a straight line. So we have that y minus y1 is equal to mx minus x1, where m is the gradient of the straight line. So what is the gradient of this directrix? Actually, the gradient of this directrix is equal to 0. Yes, see it. Let's determine the gradient. Gradient is y2 minus y1 upon x2 minus x1. So this is y2, x2, y1, x1. So it will now be minus a minus, what's y1? Minus a. What's x2? That's x. Minus, what's x1? 0. Minus a, this is minus a plus a. Minus is a plus, so it's going to give us 0. So I'm going to take 0 upon x, which is equal to what? 0. So the gradient of this directrix is 0. That means we are saying that y minus y1 is equal to 0 into x minus x1, because the gradient is 0. Actually, x1 here, we are saying that x1 is what? 0, right? This is x1. This will give us 0 at the end. 0 times everything here is still 0. What's y1? This is y1 minus a. Minus a. So we're having y minus is a what? Is a plus. So if we make y the surrogate of the formula, y is equal to minus a. So the equation of the directrix is y equal to minus a. So I can put it here, y equal to minus a. Okay, just keep watching and see what is the next. Now, let me say something. We are considering the y-axis, in this case, as the axis of symmetry. Okay, axis of what? Symmetry. We said this line is the directrix, all right? This is a variable point on the parabola. This is a variable point on the what? The directrix. This is the focus, and the vertex is at the origin. So, if the y-axis is the axis of symmetry, what is axis of symmetry? When we hear symmetry in maths, actually, axis of symmetry explains this. Look at this graph. If I try to bend this graph in this manner, the graph will perfectly overlap. It will close up completely. Okay, that is what we mean by axis of symmetry. So this graph, the parabola, is symmetrical along the y-axis. So we also consider the case where the x-axis is considered as the axis of symmetry. But for this case, we are considering the y-axis as the axis of symmetry. So what is the equation of the parabola that has its vertex at the origin and this focus, and also the y-axis is the axis of symmetry? Remember the definition of a parabola. The distance from the focus to this point is equal to the distance from point to this point on the directrix. So we are saying that FP, line FP, is equal to line PQ. This is the basis for determining the equation of a parabola. So using the formula for distance between 2 points, that says the distance between 2 points is the square root of x2 minus x1 squared plus y2 minus y1 all squared. Let us determine the distance between the focus and this point P. Let this be x1 and let this be y1. Let this be x2 and let this be y2. So the distance between the focus and the point is x2 minus x1 all squared. That's x minus 0 squared plus y2 minus y1 all squared. That's y minus a all squared. Is equal to the distance between this and this. So let's label again. Let this be x1 Okay, and let this be y1. Let this be x2, and let this be what? y2. So this is it. The square root of x2 minus x1 all squared, x minus x all squared, plus y2 minus y1 all squared. That's minus a minus y all squared. If we take the square of both sides, the square root will be eliminated. So we have x minus 0 squared, which is x squared. Y minus a all squared is equal to this. This is 0, right? Okay, so we're having minus a minus y all squared. Let's simplify it. S squared. If I expand this, I'm going to obtain y squared minus 2ay plus a squared, which is equal to, if I expand this, I will obtain a squared, okay, that's minus a squared, 2 times minus a times minus y, plus 2ay, okay, plus y squared. You can expand it on your own and see how it's going to give us this. So y squared can take away y squared, all right? A squared can take away what? A squared. So what do we have? X squared minus 2ay is equal to 2ay. That's what? 2ay. If this minus 2ay cross, it turns to plus 2ay. So 2ay plus 2ay is 4ay. This is the equation of a parabola that has this point as the focus, and the vertex is at the origin, and also the y-axis is the axis of symmetry. Now, what is the equation of a parabola where the x-axis is now the axis of symmetry? Let us define the coordinates of the focus. Let this be the focus, and this is the origin. Okay. At this point, x is not 0, but y is 0. Of course, y is 0. So let's say from here to here, which is from the origin to this point of the focus, is a unit. For y, it is 0 units. So let this be the coordinates of the focus. Now, let us fix a variable point on the parabola. Okay, let's call this point P, S, y. Okay. Now, this is the focus and this is the point. Let's connect the two lines together. Pardon my drawing. It's not a perfect diagram. Okay. By the definition of parabola, the distance of this point from this focus is equal to the distance from this point from the directrix. Okay. So let's draw the line. Let's assume these two lines are equal. What is the equation of the directrix? Remember, where the y-axis is the axis of symmetry, the equation of the directrix is y equal to minus a. So now the x-axis is the axis of symmetry. So the directrix has the equation x equal to what? Minus a. This is it. This is the positive x-axis, and this is what? The negative x-axis. This is the positive y-axis, and this is the what? The negative y-axis. So we said that from the origin to this point is, let's say, a. So to the left, it should be minus a. So this point here is x is minus a and y is 0. Let us impose a point here on the directrix. All right. The distance from here to here is the same as the distance from here to here. So if x is minus a from here to here, then it is also what? Minus a from here from here to here. But it is not 0 here. It is not 0. So it is, let's say, y. So what is the equation of the parabola? By the definition of parabola, the distance of the point on the parabola from the focus is the same as distance from the point from the what? The directrix. So using the distance formula that says distance is the square root of x2 minus x1 all squared plus y2 minus y1 all squared. We have PF, or let's say FP. FP is equal to, okay, let me label this point as point Q. PF, FPQ. All right. Let this be x1, y1, and let this be x2, y2. So going by the formula, we have the square root of x2 minus x1. That's x minus a all squared plus y2 minus y1 all squared. Y2 is y, y1 is 0. So y minus 0 all squared is equal to the square root. Pardon the way I'm writing it. Okay. We have the distance from here to here. So let this be, okay, s2, y2. Let this be x1 and let this be y1. So x minus minus a, x minus minus a all squared plus y minus y all squared. So if we take the square of both sides, the square root will be eliminated. Okay, we have x minus a squared plus, this is y squared, equal to, this is s plus a squared. All right, y minus y is 0, so plus 0 squared, that's 0. If you expand this, we have s squared minus 2ax plus a squared plus y squared equal to, let's expand this, s squared plus 2ax plus a squared. A squared will cancel a squared, all right? S squared will cancel s squared also. So what do we have? We have y squared minus 2ax is equal to what? 2ax. So if minus 2ax crosses it, is now 2ax plus 2ax. So y squared, rather, this is y squared. Y squared is equal to 4ax. 4ax. Look at something. Let us make a slight modification to the formula that we have seen. When the focus for this first parabola has the points 0, a, we said that the equation of the parabola is x squared equal to what? 4ay, right? Yes. This is because the value of a here is positive. It is greater than 0. But when the parabola opens downwards, okay, when it opens downwards, in this case now, it opens upwards. Here, it is the positive y-axis. The positive y-axis. That is why a is positive. So this is the negative y-axis, all right? So we're having 0, minus a. Do you get it? This is the positive y-axis. That is why all the points here are positive, including this a. So here it is negative. The equation of the parabola will now be x equal to minus 4ay. If we replace a with minus a, this is what we have. So in this case now, a is less than 0. Here, a is what? Greater than 0. So when the parabola opens upward, this formula is true. When it opens downwards, this formula is true. Remember what we said about this? When the parabola opens to the right, okay, the focus is at a, 0. And we said that the equation is what? Y squared equal to 4ax. Because a is positive, greater than 0. This is the positive x-axis. The positive x-axis. But when the parabola opens to the left, okay, this is the negative x-axis, this direction. So A here will now be minus. So what happens to this equation? The equation will now be y squared is equal to minus 4ax, because a is less than 0. The parabola opens to the left. Take note of this. The formulas have been summarized here. Y squared equal to 4ax, y squared equal to minus 4ax, x squared equal to 4ay, x squared equal to minus 4ay. So we use this when the parabola is symmetric with respect to the x-axis, okay? And we use this when the parabola is symmetric with respect to the what? The y-axis. Now, let us find the vertex, the focus, and the directrix of the parabola that has these equations. Let's start with the first one. Y squared equal to what? 8x. So what is the vertex of the parabola that has this equation? Looking at this equation, I can easily compare it with this. Y squared equal to 4ax. Okay, so the graph of this parabola will look like this. Let's say something like this. Pardon my drawing. This is the directrix. It will open to the right because it is symmetric with respect to the what? To the x-axis. So if I compare this equation with this, 4a is equal to 8 here. 4a is equal to 8. And this implies that a is equal to what? 2. So a is equal to 2. That means here the focus is at this point, 2, 0. That's what it means. So this is the focus. The focus has the point 2, 0. Okay. What is the vertex? The vertex is at the origin. Let V be the vertex. Is at the origin. And the vertex is at the origin for all these equations here. For the directrix, we said that if it opens to the right, where it is symmetric with respect to the x-axis, it is x equal to what? Minus a. Alright, that's what it is. But do you know that if it opens to the right, sorry, if it opens to the left, we have something like this. The directrix will not have this equation. Do you know why? The value of a here will be negative. So we'll be having x into minus, sorry, x equal to minus a. X is equal to what? A. That will be the directrix of this parabola. So maybe we are going to see this when we get to this point here. So for this, the directrix has the equation x equal to, what's a? 2. So it is minus 2. Minus 2. That's it. Now for the second one, where it is y squared equal to minus 4x. Now, if we compare this with this, okay, we have minus 4 equal to 4a. And this means that a is equal to minus 1. Okay, so a is minus 1. That means we have this kind of parabola that opens or faces the left. So let's say this is minus 1 and 0. So it is easy to say that the focus of this parabola has the coordinate minus 1, 0. Alright, this is 1. The vertex is still at the origin. The directrix has the equation x equal to, I told you for the standard form is this, x equal to minus a. But since a is minus here, which is minus 1, we'll be having minus 1. That means x is equal to 1. This is the equation of the directrix. Now, looking at the third one, we have x squared equal to minus 12y. Okay, if we compare this equation with this, we can see that it has a minus here. All right, yes, there's a minus here, which implies that the parabola will open downwards. So the graph will look like this. Pardon my graph. This is a rough sketch actually. Okay, the directrix is here. Normally, the standard from here will have the parabola opening upwards. The directrix has the equation minus a. Okay, the focus is this 0, comma a. That's the coordinate of the focus. But since it is opening downwards, a becomes negative because this is the negative y-axis and this is the positive y-axis. So we're having the focus at 0, comma minus a. Okay, and the directrix will now be y equal to minus a, because there was a minus here, and the a here is also negative, so it should now give us plus a. I hope you get it. The focus here has the point. If we compare this with this, it is obvious that a is minus 3. Minus 3 times 4 is minus 12. So a is minus 3. That means we'll be having 0, comma minus 3 as the coordinate of the focus. The directrix, we have the equation. What's a? We are taking a positive a here. Alright. The equation of the directrix will be, the directrix will have the equation y equal to 3. Yes, it is 3. The standard form says y equal to minus a. So where a is minus 3, so now be y equal to minus 3. That's plus 3. So this is the directrix. The vertex is still at the origin, 0, comma 0. So I wanted to solve this. Determine the vertex, the directrix, and the focus of the parabola that has this equation. All right. Solve it and drop your answer in the comment section, and I'm going to review it. Okay. All right. Thanks for watching. This is not all for parabolas. Later on, we're going to consider the lactose rectum of a parabola. Okay. The line that passes through the focus and joins 2 points on the parabola. We're going to consider it later. So for now, stay tuned, keep following, like this video, and share it with your friends and your course mates.